those who are interested to have a career in embedded IoT, let us start with understanding what are the essential modules which you have to learn as part of this module. You can see a lot of overlap between embedded systems and IoT roadmap. To start off with, in stage 1, we're going to cover about understanding the IoT architecture and how each components are going to work together as part of the final end-to-end IoT solution. We'll start with giving an overview about IoT architecture first. Following that, we're going to use a similar pattern or similar stage-based development for IoT course as well. To start with, we'll help you build your foundations by teaching you C, C++, and Python programming. So C and C++ is commonly used to develop embedded applications as well as in IoT applications to develop sensor nodes and the likes. Python will be used at a later stage more often when you're going to use IoT gateway and protocols to get data from different sensor nodes and interact with the cloud platform. Python is also used in other areas including developing test cases and also building your CI/CD pipeline. After learning the foundations, we'll move to stage 2. In stage 2, we're going to cover microcontroller programming using ESP32 and Arduino. You may have this question, why ESP32 and Arduino? Our focus of IoT module is to learn how to build end-to-end IoT solution, starting from getting data from sensors and maybe actuating it by giving some commands, and learn how to use this data and connect with an IoT gateway and cloud to derive meaning out of it. So in this module, we're going to cover about how you can interface and program microcontrollers like ESP32 and Arduino, which is relatively easy to start with. In this module, we'll also discuss on how we can get this data and communicate this data to other devices using wireless protocols like Wi-Fi and Bluetooth. Now, Wi-Fi and Bluetooth are integral and essential part of building IoT applications. In embedded systems, we may not be focusing much on transmitting this data to other devices or to the cloud. You're going to focus more on getting this data and sending to other devices or sending to the cloud so that you can derive meaning out of it. Here, you may end up using mobile applications which facilitate you to monitor the data from Bluetooth and Wi-Fi. For example, applications like Blink are easily available for you to use. Moving to stage 3, after learning how to interface sensors with Arduino and ESP32, it's important for us to leverage this data and collect all this data from several nodes which are independently connected to different machines or independently monitoring the parameters. After learning how to develop applications using Arduino and IoT to get sensor information, we'll move to the next stage. In stage 3, we're going to learn about IoT protocols and gateway. So when you talk about these sensor devices, often there are use cases wherein these sensor devices directly communicate to the cloud, or you may have hundreds and thousands or even millions of devices sitting in an industry, getting this information and communicating to the cloud via a gateway. Learning about gateway is also important if you want to build complex IoT applications wherein these nodes interact with each other. So we will use a platform like Raspberry Pi to set up and build IoT gateway and to interface with the sensor nodes. In this module, you learn about protocols like MQTT, which is a publish subscribe protocol. This protocol is quite popular among IoT developers because it allows you to communicate large amount of data with less bandwidth. Other protocols like COAP and HTTP also will be covered. We learned about Python programming in stage 1. In stage 3, to build more complex applications, we'll be using Python to program the MQTT protocol and communicate with the cloud as well as communicate with the devices. We can also get data from Bluetooth and Wi-Fi from sensor node as well, or legacy protocols like UART and the likes. In last stage or stage 4, we're going to discuss about IoT cloud. IoT applications are more meaningful if you're able to get this data, store it in a cloud platform like AWS or Azure IoT. There are several other IoT platforms available as well. But fundamentally, our idea is to make you understand how the data from the sensor node and gateway can be ingested into a IoT cloud platform. This data can be used for monitoring and analytics at a later stage. IoT cloud platform also can be used to control the devices remotely based upon your business use case. If you compare embedded systems roadmap and IoT roadmap, you can see there is a lot of overlap and similarities. In stage 1, we are covering about programming languages like C and C++ in embedded systems, whereas in IoT, we have included Python additionally. This gives you an edge. Similarly, when you talk about stage 2, we're going to cover about microcontroller programming. If you compare embedded systems with IoT, more or less the topics remain the same, only with the addition of protocols like Bluetooth and Wi-Fi in IoT. Other difference is the controller which you're going to use can differ. Similarly, in stage 3, in embedded systems roadmap, we discussed about Linux internals. Here, we're going to focus on IoT gateway and protocols. In the end, in stage 4 of embedded systems, we discussed about how to build Linux from scratch, as well as understanding the different stages involved in building a complete embedded Linux application. In the final stage of embedded system roadmap, we discussed about modules including embedded Linux on ARM and embedded UI development using Qt-QML framework. In IoT roadmap, we discussed about IoT cloud platform in detail. So with this, I hope you got a clear understanding about the roadmap for embedded systems and IoT. What are the similarities and differences we cover as part of our 2 set of courses.
And with this, we have come to an end with this video. Roadmap from beginner to embedded systems and IoT professional. If you have enjoyed listening to this video, please like it and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists and subscribe to Emertxe's YouTube channel to learn more. Thank you for watching.
Be it embedded systems or IoT, our learning approach remains the same for both these courses. We use a project-based learning approach, wherein in each of the stage, you learn about the modules. We also have ensured that you're using SDLC-based development to build the project. SDLC stands for Software Development Lifecycle. In SDLC model, what goes into the header file, what goes into the source file, etc. Often this is confusing for beginners. To begin with, we'll try to build a background to understand how ECUs work. This project-based learning will give an edge over others in your team.